In this video, I'll be showing you how to calculate the pH of a weak acid using equilibrium. So before, when you calculated pH, you were doing it with strong acids. And the calculations were straightforward in that process because strong acids dissociate completely into H plus ions, which means if you knew the concentration of the acid, you also knew the concentration of the H plus ions. For weak acids, that's not necessarily the case. Weak acids exist at equilibrium with their ions. So in our example here, we have hydrofluoric acid. So the dissociation reaction for hydrofluoric acid would look something like this. So here you can see our hydrofluoric acid is at equilibrium with H plus and F minus, which means we'll need to set up an ice table in order to figure out the concentration of H plus so we can take the pH. We're also going to introduce this new item here called the pKa. And the pKa is another way you can measure the strengths of acids. And it's based off of the Ka, which is the equilibrium constant for acid dissociation. So we're going to need to get the Ka from this pKa value in order to set up our equilibrium expression to solve for x. And pKa works very similar to pH. Remember, for pH, you took the negative log of H plus. Well, pKa is the negative log of Ka. So to get the Ka out of this, you simply do the inverse operation. You'll take 10 to the power of negative pKa, and that will give you the Ka for this reaction. So if you calculate that, you should get 7.94 times 10 to the negative 4 as your Ka. So now let's go ahead and set up our ice table for this reaction, given that our initial concentration of hydrofluoric acid is 0.3 molar. So here's our blank ice table for this reaction. Let's go ahead and fill in our values, that way we can work towards our equilibrium expression. So the question tells us that we start with an initial concentration of 0.3 molar for the hydrofluoric acid. So that's going to go in the initial category for HF. And you're initially going to start with 0 products. Now some professors will have you take the concentration of H plus in water as your initial H plus. However, the amount is so small that it really doesn't matter at the end. So you can just say that this is 0. And of course our F minus concentration is 0 initially. Now each of these are going to change by a factor of x, and each of them have a 1 in front of them. So HF is a reactant, therefore it decreases by a factor of x. H plus is a product, it's going to increase by a factor of x. And F minus is a product, and it increases by a factor of 1x. So at equilibrium, the concentration of HF is going to be 0.3, which is your initial concentration, minus that x factor that you change by over the course of the reaction. H plus and F minus are both going to be just x at equilibrium, because they start at 0 and they increase by a factor of 1x. At equilibrium, they're both just x. So now we can take these values at equilibrium and use them to set up our equilibrium expression. So here's the generic equilibrium expression for this reaction, where we have the Ka is equal to the concentration of H plus times the concentration of F minus over the concentration of HF. So if you plug in our values, our Ka is 7.94 times 10 to the negative 4, and that's equal to x times x over 0.3 minus x. So now we need to rearrange this equilibrium expression into the form of a quadratic equation. So watch the previous video on equilibrium with quadratics to go through the algebra of how to rearrange this into quadratic form. I'm just going to go ahead and skip to the final form of this equation. So now that we've got this in quadratic form, you decide which avenue you want to go down to solve for x. If you have the quadratic formula programmed into your calculator, feel free to go ahead and do that. or if you want to do it by hand using the quadratic formula, that's fine too. For a full overview of how to use this in the quadratic formula, see the previous video on how to do the algebra of the quadratic formula for these equilibrium problems. So you should get your x as equal to 0.015. And now we can take this value and plug it in for x. Because to calculate the pH, all we really care about is the concentration of H plus at equilibrium. So to solve for the concentration of H plus, you simply plug in your value of x. And that's going to equal 0.015 molar. Now to calculate the pH, remember that pH is equal to the negative log of H plus concentration. So to take the pH of this, we would do pH is equal to the negative log of 0.015, which is our H plus concentration at equilibrium, and this will give you the pH of this solution of acid. And if you do this calculation, you should get right around 1.82 as your pH of this hydrofluoric acid solution. And that's how you use equilibrium to calculate the pH of a weak acid.